So for our capstone project, we're going to talk about why do so many drugs resemble the structures of serotonin and dopamine.
My name is Paris Lamb.
My name is Fayruza Farrow.
My name is Olivia Saferni.
And my name is Dara Pierre.
So first, what is dopamine and serotonin? Both dopamine and serotonin are neurotransmitters, and what a neurotransmitter is a chemical messenger that carries signals between neurons and other cells. Both dopamine and serotonin interact with the brain's reward system, and they're often referred to as happy hormones due to their mood-boosting effects. On the right, we have an image of both the chemical structures of serotonin and dopamine, and you can see that the HO, that's a hydroxyl group, that's important when it comes to chemical bonding.
When drugs enter the body, their charge dictates their drug receptor interactions. For example, receptors that can interact with drugs have specific three-dimensional shapes, which require a specific chemical structure to bind to it. Changes within the molecular shape dictate the specificity of a receptor. Numerous drugs are made of an acid and an amine group, an amine functional group, which leads to the ionic bonds being formed between drugs and receptors. These ionic bonds are driven by the opposite charges located at receptor sites. Hydrogen bonds that form between polar molecules are also caused by oppositely charged interactions, which occur between a drug and its receptor site. And this is the information that we found that helped relate our question of why so many drugs resemble the structures of serotonin and dopamine to Chem 1033. And for our next slide, we pulled a picture that focused on dopamine, how dopamine is released when food is ingested or when a person uses heroin. And this further explains how neurotransmitters are released depending on the binding of a substance and the charge and the shape.
Addiction happens because drugs take over the brain's natural systems. Some drugs act like the brain's own chemicals, tricking it into activating responses it normally wouldn't. One major effect is a dopamine rush. Drugs flood your brain with feel-good chemicals, creating a strong connection between using the drug and feeling pleasure. Over time, the brain adapts and starts producing less dopamine on its own, making you rely on the drug just to feel normal. Fast-acting drugs, like those you smoke or inject, hit hard and create an intense high, which makes people want to use them again. On top of that, drugs can help make people escape stress or negative emotions, which makes the habit even harder to break. In the end, drugs rewire the brain, making addiction much easier to develop.
How similarities between the chemical structures of serotonin and dopamine and drugs aid medical advancements. Serotonin and dopamine are both neurotransmitters that play key roles in mood regulation and cognition. Drugs, particularly psychiatric medications, are designed to influence these systems. Understanding how drugs mimic or interact with serotonin and dopamine at the molecular level can help through a list of things. Improving drug design. Scientists can design drugs that closely mimic the activity of these natural compounds, reduces amount of side effects. Researchers can avoid stimulating other receptors that might cause side effects to the patients, enhances drug efficiency. When a drug closely resembles a neurotransmitter, it can bind more tightly and efficiently to its target receptor. Refine current drugs. With new and more specified knowledge on drug functions and structures, current drugs can also be improved. Improve diagnostic tools. Understanding molecular structures of serotonin and dopamine allows for development of more sensitive imaging agents and biomarkers. Ability to create drugs tailored to an individual. Knowledge of serotonin and dopamine pathways can guide clinicians in selecting the right drugs and dosage based on an individual's unique genetic makeup. And to the right, I have a picture of drugs as well as serotonin and dopamine. And as you can see the similarity in the structures, which is what our project is on. And using these similar structures, we can aid in medical advancements. And this is our works cited page, and that is our chemistry capstone. Thank you.